Hi there viewers, this is MathCamp321 presenting a question like number 22 from chapter 9.7 of your textbook, Geometry for Enjoyment and Challenge. In this question, you're asked to find the length of the altitude drawn to the base of the isosceles triangle shown in the diagram. So the first thing that I want you to recall in looking at a problem like this is the isosceles triangle theorem, if sides then angles. This theorem is going to tell us that the base angles of this isosceles triangle are congruent. So I'm going to go ahead and mark those with tick marks. The other theorem that I need to know is the theorem that tells us that all of the angles of a triangle total 180 degrees. This is the triangle sum theorem. Now, if the angle on top, the vertex angle, if this has a measure of 120, that means 180 minus 120 is 60. There's 60 degrees left over, and that 60 is going to be divided equally for the two remaining base angles. So each base angle is going to have a measure of 30. So I'm going to go ahead and mark that in the diagram. Now, the next thing I'm going to do is I'm going to draw in the altitude, because that's what they're asking us to find. So I need to draw an altitude from the very top, the vertex angle, to the base. Remember that an altitude is a line segment drawn from any vertex of a triangle such that it forms right angles with the side to which it is drawn. So I'm going to draw a line straight down from this vertex angle. And I'm going to go ahead and put right angle marks to indicate that it is in fact an altitude. The next thing I'm going to do is I'm going to put tick marks showing that this altitude or this green segment is congruent to itself using the reflexive property. Now that's important because when I've dropped this altitude, by dropping this altitude, I've formulated two smaller right triangles on the inside, and I'm going to designate them with Roman numerals 1 and 2. Now these two right triangles are congruent by the HL theorem. Because the two triangles are congruent, I also know that their corresponding parts are also congruent by CPCTC. And this tells me a few things. The base of the one triangle is the same as the base of the other right triangle. So I'm going to put tick marks there to indicate that. And it also tells me more specifically that the overall base of 24 has been split into two pieces of equal length, 12 and 12. Also, because of CPCTC, we know that the angle that is labeled as 120 at the top has also been split into two equal parts, each being 60. So I'm going to go ahead and label those. So this diagram has a lot going on. There's a lot labeled, and it's becoming a little bit overwhelming. But one thing that you learned in this section on special right triangles, specifically the 30, 60, 90, is that there's a special pattern. And that pattern is modeled after this picture, which I'm going to review with you right now. So here's our right triangle, and a 30, 60, 90 right triangle. And across from the 30 degree angle is the short leg, which I'm going to call x. And across from the long leg, which is across from the 60, I'm going to call that x root 3. And across from the right angle, or the hypotenuse, that's called 2x. And all 30, 60, 90 right triangles follow this pattern. So if you have a 30, 60, 90 and you have one of the sides, you can figure out any of the other sides. So that's precisely what we have here. So what I'd like you to do is I'd like you to focus on Roman numeral 1, and I'm going to redraw that actually off to the side because there's so much labeled and there's so much going on that it's going to be kind of hard to see. Okay, so I've redrawn Roman numeral 1 down here, and what we're given here is the long leg, and I know it's the long leg because it's the side that's opposite the 60 degree angle. So this guy right here is the long leg. And what I want to find is I want to find the length of the altitude, and the altitude is the green segment, or it's now this segment over here to the right. And that's across from the 30 degree angle, so that means it's the short leg. So what I'm doing is I'm trying to move from the long leg and find the length of the short leg. So looking at that over here in this diagram, I want to go from the x root 3 side to the side that is just x. In other words, I need to get rid of the root 3. And to do that, I'm going to divide by root 3. So I start with 12. I want to remove the root 3 by dividing by it. I need to rationalize the denominator. Then I'm going to multiply across in the top and I get 12 root 3. And I go across in the bottom and I get 3. And the 12 and the 3 cross cancel or reduce to just plain old 4 root 3. So the length of the altitude in this triangle is 4 root 3. Now, just for fun, just to extend this a little bit, what if I'd asked you to find one of the legs of this isosceles triangle? See where I put the question mark? Let's put that over here. That's the hypotenuse. So let me label this hypotenuse. And if I'm given the short leg, which is x, to go to the hypotenuse, it's 2x. I just double it. So if the short leg is in fact 4 root 3, and I take 4 root 3 and I double it, then I'm going to get a hypotenuse that's 8 root 3. So this leg of the isosceles triangle is 8 root 3. And because it's isosceles, that means this leg over here is also 8 root 3. And just to further torture you, let's add another question on. Let's say I wanted to find the perimeter of this triangle. The perimeter would be when you add up all the sides. And I'm talking about the big triangle, not the two smaller ones on the inside. But the perimeter is going to be 24, which is the base, plus 8 root 3, plus the other 8 root 3, which is 16 root 3. And these cannot be combined because they're not like terms. Many students think that maybe you can combine them and say that it's 40 root 3 or something like that. But think of it like if you saw the number 10 plus x. You'd have to leave it like that. You wouldn't be able to say 10x. So think of that root 3 like an x. So 24 plus 16 root 3 is as far as you can go with that. So in this problem, we found the length of the altitude, we found the length of each leg of the isosceles right triangle, and we also found the perimeter of the big triangle. A lot going on here. My teaching tips to you would be redraw things separately off to the side where it might be a little more clear. My other tip would be to label like crazy. The more you label, the better chance you're going to have of figuring out what it is you're looking for. I hope this video helped, and now if you want, go to section 9.7 of your book and try the version of number 22. You should be able to do it now that you've seen this problem.